Okay, so I am Dan McManus. I am the co-instructor for the course. Interacted with a few of you on Canvas and even met one or two of you in person as well. So we're just going to do a quick review over some of the items that were brought up in the discussion for the review section for today in preparation for Exam 1. Now I'm not going to cover every single item. I'm going to try to group them as possible just to keep this as concise and exactly for what you need for the exam tomorrow. So the first thing we'll discuss are limits. There are some questions about real upper limits, real lower limits. And when we talk about limits, most of the time it has been in reference to histograms and how those bins, BINS, bins are created. And the theory or the idea is that imagine you had a trash bin. And we might say 50 for that trash bin, but not everything that fits in that bin is going to have the value of 50. It's going to have some sort of lower limit and upper limit, and this is the general concept of what we've been talking about. Now, what you'll need to know in preparation for the exam isn't how to use these in order to create a histogram. That's a practical application that the lab portion is really for the SPSS. Instead, what you'll want to know is just the concept of what real upper limits and real lower limits mean, and generally it's going to especially apply to the real lower limits. So the best example I can give you is, let's say you were given the highest value of the data set is 100 and the lowest is 50. Instead, find the range. You would think 100 minus 50, the range here is 50 for this data set. And that would be true. But then let's say I asked you, do this, tell me the range, how many values are between 100 and 50 using the concept of real limits. Your answer would actually be 51. Now, why is that? Well, that's because if you grab any calculator and you do 100 minus 50, you're going to get 50 because it doesn't take into account real lower limits of 50. It's actually not including 50 when you do 100 minus 50. It's basically going 51, 52, all the way up to you hit 100. So really what's going on there is that when we say consider the real lower limit, it means anything that is 49.5, rounding up and above, is going to be within that bin, or it's going to be contained within that range. So that means including 50. So 100 minus 50, including that 50, would give you 51 because you're going 100 minus anything that's above 49.5. Now remember that in these bins there are a continuous range of data, so 49.1, 49.2, 49.3, all those would fall into the bin with 49. But when we get up to 50, that means 49.5, 49.6, now 49.5, at and anything above is going to fall into that bin of 50. So that means the value of 50 needs to be included, and that's how we get to 51 as the number of values between 100 and 50. Alright, so the next thing we're going to cover quickly is box plots, also known as box and whisker plots. I'm just going to call them box plots. So I think the biggest concern over these appears to be how to calculate them and construct them based off of those calculations. For the exam, and really for any practical purpose, you will not need to calculate and construct a box plot on your own in that manner. Again, that is where the usefulness of SPSS in the lab comes into play. You will need to know how to interpret and understand a box plot. So I will touch on briefly what some of the basic ideas are that go into the calculations of a box plot, but it's important to understand the idea more so than those calculations. So let's take something you saw late in chapter 6, late in the course, comparatively, that is a normal distribution, also known as a bell curve. And we tell a lot by this distribution. Now this bell curve sort of comes off of a histogram. That's why we use them pretty much interchangeably when we talk about distributions. So this bell curve is what we want. We have a little bit of data on one extreme end and on the other extreme end, but most of our data fall right in between in the middle in our large unimodal hump here. Now let's imagine that I took this distribution and I rotated it clockwise 1 turn or 90 degrees. And excuse the drawing if it is not very accurate. So it would look like this if we rotated that normal distribution. Okay, well then let's also mirror and reflect that distribution, and this is what you would get. So this is basically a box and whisker plot. It's just curvier. So a box and whisker plot is just another representation of the distribution, where you can look at the tails here to see, to inspect for skewness, to inspect for outliers. Again, if we see a tail that extends way out here, we say it's skewed in that direction. It'd be positively skewed. The same would hold true for a box and whisker plot if the whisker was way out there. So it's really just another mechanism of looking at a distribution. You just essentially looked from a top-down perspective on top of a distribution instead of looking at it from the side, which is what we're doing with a histogram, normal distribution, or distribution view. Now, as far as the calculations, again, you will not need to calculate by hand, certainly, and you will not be using SPSS during the exam. You will not need to calculate those items necessary for constructing a box plot. Now, if you just want to know what does go into it, is essentially within a box plot, let's draw a new one over here, the median for the entire data set is identified. Now, the median may not be in the middle, it may be down here. And I think an example in your book, indeed, is like that. But the median is first located, and then essentially the median for those two sections is found again. But really what you're doing is finding the 25th percentile for the data, and then the 75th percentile for the data. Now, if you see it like this, you would also, just like over here, expect this must be a skewed data set if you see all these lines down towards one end or the other. And maybe you'd also be able to confirm that by seeing how far out these whiskers extend also. So that's essentially what's going on with the calculations, is the 25th percentile. Once you have the median, the 25th percentile, then the 75th percentile are obtained. And anything between the 25th and 75th percentile, anything that falls in here is called the interquartile range. That goes into calculating how far out these whiskers extend. You will not have to do that for the exam, but understand at least how they are constructed. Not how they're constructed, but understand what they represent. They represent a distribution just like a normal distribution would. It's just another method of doing it, and also it is not mean-based, it is median-based. Okay, so I will end this portion of the video and I'll start a new one for the other items.